So today, if you are given the probability of success and the sample size and the confidence level, you can find the interval. So we expect things to be around the mean, but we need to know an acceptable range of answers, and depending on the confidence level and the sample size, that range can fluctuate. So we are going to calculate a confidence interval and find out acceptable values. I know we've went back to it every single day almost. Go back to the ghost problem. The CBS poll where we asked people if they believed in ghosts. All right, so let's just... All right, so first of all, you guys know the probability of success. What was the probability that people believed in ghosts? You guys remember? 0.45. What was Q? 0.55. So 45% of people believe, 55% don't. And what was our sample size? All right, 808. So the only thing that we don't have for this formula is the z-value. So let's first, just because it's the most common, let's do a 95% confidence interval. So the interval is a range of numbers, and it's going to tell you the lowest acceptable value and the highest acceptable value. We obviously we expect our answers to be around 0.45. But we have to decide like how high is, or how much is too much, how low is too low. So in order to do this, if we know we're doing a 95% confidence level, this helps us find Z. Now this is one I told you to remember. You guys remember what it is? 1.96. 1.96. Now we did that in our notes yesterday, but if we didn't, we would draw the curve, we would find out the tail is 2.5, we would look for 0.975 on the chart, and then it would go to perfect 1.96. So on this, we now have everything we need to plug it into the formula. So let's plug it in. We know P is 0.45 plus or minus. Our Z value is 1.96. And then inside the square root, remember this is standard deviation. We've done this before. But our P times Q goes in the numerator, and our our sample size goes in the denominator. So now from this point, we just use our calculators to find out these numbers. So let's grab our calculators. And let's calculate that second half. What is after the plus or minus? You can type this all in one step. Because we want to try to do this as few steps as possible, so that way we're not rounding and then rounding and then rounding, because the more times you round, the less accurate your answer is. So on the calculator, we are going to type in 1.96, then you're going to put in your square root, and then inside the square root, you can just go 0.45 times 0.55 divided by 808. And it's going to give you a number. All right, we're going to round this to the nearest 1,000. So once you plugged all of that in, what did you get? 0.034. So this number that we calculate here, this is actually what we call a margin of error. So the margin of error is giving you just that reasonable percentage of how much above the mean and how much below the mean. In this case, that's around 3%, right? So we would expect numbers to be around 0.45 and 3% above that and 3% below that. So we are going to write our interval, and for those of you that had Mr. O'Brien, you know, we always write intervals like this. All right, our lower bound always goes on the left. So how am I going to get the smaller number? By adding or subtracting? All right, we're going to subtract to get the lower number. All right, so everybody, let's take 0.45 minus 0.034. what you get. 0.416. And then to add, that's going to give us the upper bound, or the highest number that's acceptable. And we add that, what do we get? Did you get 474? Is that what you said? Okay. All right, I just want to make sure you didn't type it in wrong. All right, so what that is telling you is if you were to do your own poll, based on the results that CBS gave us, we would expect people, we would be 95% confident that if we were to do this study on our own, that we would have somewhere between 41.6% and 48.4% saying that they believed in ghosts. Now, if we did a study and we had like an 80% success rate, that would probably red flag us to know we've either made a mistake in our sampling or the way we've worded our question. There's some sort of bias that would probably throw off answers like that. We would be expecting numbers in that range. So that is actually called the confidence interval. The interval gives you the lowest and the highest number. Now, today's assignment, you are just told to calculate it. You also will be told to interpret it. And this is where this is going to be super helpful for the AP test. So if you are interpreting a confidence interval, you're telling me what those numbers mean pertaining to the subject. I know it really doesn't take a lot. You're just essentially repeating everything that you were doing here. But this is what we would write for this. So if I told you to interpret the confidence interval, probably should make sure the camera is on me before I start writing. Okay. All right, so if we are interpreting that confidence interval, you're just writing a statement explaining what these numbers mean. So first of all, how confident are we? All right, so the first thing you're going to say is, I am 95% confident that. All right, now in this case, we're talking about probabilities or proportions. So the proportion of people that believe in ghosts. You say it's between. What two values do we expect our answers to be between? So whenever you are writing a statement, these are the three things that they will be checking on the AP exam. They want to know how confident you are. They want you to find out what you're actually calculating. In this case, it was people that believe in ghosts. They want you to list what the success is. And then they want to know the lower value and the upper value. So you're just explaining what those two numbers mean. When it says interpret, you're just talking about what your answers mean in the context. And that is it. It's not asking you to do anything else. It's just the numbers that you were given. You're just putting it in. You're explaining that you know what the numbers mean. So do you guys have any questions about the formula part? Typing it into the calculator? Now what about writing the statement? Is that... Okay, so I actually want to do this exact same problem. Go ahead and answer that, Will. And I want you to, this time, I want you to use the same same topic. We're still talking about the ghost, but I want to be 98% confident this time. Thank you. All right. Oh, I wasn't even looking. Well, there's a magnet on it. They're real, like, that keeps it where it's at. Will, it's all right. Okay, I want to do this exact same problem, but this time we're going to be 98% confident. So, you would trust somebody that's 98% confident before you would a 95, right?
I trust both of them.
Well, which one's better, 98 or 95?
Oh, 98, but I have to know them on a personal level.
Well, you have to know them on a personal level.
We don't have that.
That's a good point. I think I trust 95.
All right, I'm actually going to start abbreviating confidence level as CL. I don't know about you, but I don't want to write that over and over again. All right, so confidence level is CL. All right, so on this one, this P, Q, or N change, the Z change. The Z value changes. That's how it's going to, when you change the Z value, it will change that second number. All right, so we do need to find out the Z value for a 98% confidence. So I'm just going to quickly, off to the side, talk about this. So if it's 98%, what am I actually going to look for in the chart? Not 0.98.
Oh,
0.99, because each tail is 0.01, and we have to include the left tail in our chart. So then you would try to find on your chart the closest thing to 0.990. So let's look. I know we did this yesterday, but let's look. Closest thing to 0.990. 9901. Now what's the one right before that? Now, is there that much difference between those two?
No.
They're both pretty close. So let's just use a Z value right in between those. So what's the Z value in between those? The 0.89 or 8989 or 8998? 2.325, because it's in between 2.32, 2.33. So whenever we plug in our numbers, we're still using the 0.45 for success. The only thing that's changing is that your Z value is going to be a little bit bigger. We're still using 0.45, 0.55, and 808. So your margin of error is going to change here. So let's see, 2.325, and then plug in your square root. Now we're going to round all of that to the nearest thousand. What do you guys get for all that? When you plug all of that into the calculator, what do we get? 0.0. Is it 41 or does it round up to 2?
Oh, it might have rounded up to 1. Okay.
It rounded up to 1? Okay. So if you can see, the margin of error is a little bit bigger. So then we're just going to add and subtract to get our range. So let's subtract first to get the lower number, and then we'll add to get the bigger number. So what do we get when we subtract 0.041? 0.409. And what about when we add? Now if I to write a sentence on this one, what would we say? How confident are we? All right, so we would say, I am 98% confident that. And say we're still talking about the proportion of people that believe in ghosts. Is between, but this time we're just using different numbers, 0.409 and 0.491. So whenever if the confidence level changes, the range actually gets bigger. So that is something I would maybe write down in your notes. You actually have a bigger range in your interval if your confidence level gets larger. So it was a smaller range for 95, it got a little bit bigger for 98. So then what if I told you to find like an 80% confidence interval? Would that be a bigger range or a smaller range? If it was 80%. And say it would get smaller. And this is a good way to explain this. And I'm going to draw on the bottom of that first page. All right, think about this with targets. I wish I could bring my dartboard in. I actually used to bring it in. But if I gave you, if we had two dartboards, if you had a dartboard that looked like this, and then another dartboard that looked like this, and I told you that you had to pick one to shoot from, which one would you pick? Why?
Because you're more likely to make it.
So you would have more confidence with the bigger target, right?
I probably saw very little confidence with
Well,
it.
I'm not saying that, you know, I'm not questioning your ability, but you would probably have more confidence throwing at a bigger target, right? So you have more confidence in the bigger target, you're going to have more confidence in a bigger range. Because the chances of hitting those numbers is more likely. When you shorten the range, the chances of hitting those numbers are going to go down. So whenever you increase your confidence level, you are going to increase the numbers on your confidence interval. So let me see, I've got one more. And this one I totally made up, and after I talked to Carly yesterday afternoon, I probably am a little low on my numbers. But let's see. All right, here we go. We're going to calculate a 90% confidence interval based on an SRS of 100 students, and it claims that the proportion is 0.85 of students who watch Netflix at school. She told me it's way higher.
Oh, yeah.
I feel like 100%.
I don't watch Netflix.
I don't watch it much this year, but last year.
Oh, yeah, sophomore year, all I did.
Well, I wonder if I said, maybe if I said during instruction.
Oh, I don't think I watch.
Well, that's just rude.
I played
Yeah.
Roblox probably more than I did schoolwork last year, but they took that away, so.
I definitely watched a lot whenever I was doing my work. I was very involved in teaching
I think I probably
All right.
Still the biggest. I know.
All right. So,
Like, if I didn't have to, if it was a class that I didn't have to give much effort in to receive an A, probably,
Okay.
but I still don't watch Netflix like now, during this year.
Spanish.
okay, I do have to ask, and sorry people that are listening to this because it's totally off topic. My interest in Netflix has gone way down because I feel like I've watched everything that's worth watching.
Oh, yeah,
Like, we've considered getting rid of Netflix.
yeah. Quarantine is-
You watch New Girl?
No. No, I don't watch New Girl. The only thing that I'm keeping Netflix for right now is The Crown.
You should watch New Girl.
But then I also saw there's a new season of Dead to Me coming out soon, and I really like that show too.
There'll be a new season of All American coming out pretty soon.
Well, Zach informs me that if I just stopped watching it, I would find something else
They
to
need to come
watch.
out with
So
some more
it wouldn't matter.
Punisher and more Peaky Blinders.
More Flash.
No.
I don't know what that is.
They have about
All
like
right.
a trillion Flash seasons.
Okay, this is our last example. We've got to focus. All right, so everything that we need there, we need a probability of success. Do we have that? Based on the random sample, what are they claiming it is? All right. So what's our probability of failure if success is 0.85? All right, because those always have to add up to 100%. All right, do we know our sample size? All right, do we know a z-value yet? Okay, pretend like we didn't do this number yesterday. Don't look back and get the answer. So, everybody have their chart? Okay, so 90% means that the middle chunk is 90%. So, what does each tail equal to? All right, they're equal to 5. So what are we going to look at on the table? 95. So get your table out and let's look for 0.95. It's in between two numbers, I will tell you that. Yes. Well, let me see. I haven't looked at it yet.
I forgot about one thing.
What part are you? Oh, like get the two answers? Here, quickly, yeah, get them done. Your two answers. You're okay.
All right. So you guys tell me, what is my z-value? Because on the table, the two numbers that 0.95 is really close to it, it's in between. 1.64 is a little less, 1.65 is a little over, 1.645 is the middle. So now let's plug this in. 0.85 plus or minus 1.645, then in my square root, 0.85 times 0.15 divided by 100. All right, so let's first figure out that second half. Let's get that margin of error. How much are we going to add and subtract by? So we're going to take 1.645 times our square root, 0.85 times 0.15 divided by 100. And we're going to round that to the nearest thousandth. I'm going to say, Annalie, what'd you get when you typed all that in?
That's what I got too. Let me see what you typed in.
Oh, you don't actually put in the plus. We're just finding out that second half, so don't worry about this. I just want this part.
I talked to my nanny in the hallway today, and she like.
Alright, so-
so.
Alright, so for this second half, you should have had plus or minus 059 or 509? 059. So then we can add or subtract to get our numbers. So I'm going to subtract to get my lower number first. What happens when I subtract that? What do I get? 0.791. And then when I add it, 0.99. All right, so this is the confidence interval. Now, if I tell you to interpret it, what would I write? Yeah, you are always confident. And what are we confident in? Proportion of students who watch Netflix at school. Is what? There we go. See, the interpreting part's really not that hard, is it? No, but guess what? That's worth like 2 points out of 5 usually, just writing that sentence. All right.
Did you write the sentence, or you just have?
It'll say calculate and interpret. So calculate just means find the numbers. Interpret means tell me in a sentence what it means. But your assignment today is just to calculate, but your quiz on Thursday of next week will have you interpret. So we only have one more lesson. We have a lesson on Monday, then we're going to review Tuesday, Wednesday, quiz Thursday. Yes. Yes, the next quiz, that'll be, because I'm not going to take grades on Friday because we're going to do stats football stuff. That's the last day of the 9 weeks. All right, and Khan Academy is, you guys have 3 of them that are due tonight at midnight. You have had all week pretty much to do those. Yeah, Monday, Tuesdays, and Wednesdays.